Good morning, everyone. So here is today's lesson, okay? Today we are learning, last class we learned how to graph in standard form, and today we're going to learn how to graph in standard form, okay? So the first thing I want you guys to realize is that, well, let's say this is standard. I'm going to write it in a different color. So this is standard, and this is vertex form. So this is what we are going to be concentrating on today, okay? But before we do that, I want you to realize that both standard form and vertex form can be the same thing, okay? So what we are going to show in this box right here is how this equation and this equation are the same exact thing, okay? So what we are going to do is we are going to take our vertex equation and try and get it to look like our standard, okay? And we know that whenever we have a squared term after a parentheses, we need to FOIL. So really what this is saying is y equals x minus 2, x minus 2. Okay, and what you can either do is FOIL or we can use the box method. So I'm going to zoom in so just I have a little bit more room. Okay, and I'm going to go ahead and use the box method. So I'm going to draw my box, okay? I'm going to have it a little bit tiny. And remember, your first parenthesis goes on top, so x minus 2. And on the left, same thing, x minus 2, okay? And then all we're going to do is multiply. So in this first box, I have x times x, which gives me x squared. In the second box, I have x times negative 2, which gives me a negative 2x. In the third box, I have negative 2 times x, which is the same thing, gives me a negative 2x. And in that last box, I have negative 2 times negative 2, which gives me a positive 4. Okay, so that's how we FOIL. Or if you want, you can always do this. So if you like to FOIL, but I think most of us like to use the box method, okay? So what I'm going to do is I'm going to go ahead and draw my z. And that tells me how I'm going to write my equation down. So I have x squared minus 2x plus 4. Okay? And then we combine like terms. My only two like terms there are negative 2x and negative 2x. So my end result will be x squared minus 4x plus 4. Okay? And I'm going to stick a y equals in front. So when I move over, I see that this is the same as this. Okay? So as you can see, once we FOIL things out, right, we can see that they're equivalent. Okay? So we are going to go ahead and do the next two together. All right, so remember, we want to change the vertex form to get it to be equal to standard form. Okay, so the first thing I need to do is PEMDAS. I need to do my exponent, right? So what I'm going to do is I'm going to write this down in a different way. I'm going to move over and zoom in, okay? Minus 1, because that's the original part of the equation. So the first thing I need to do is FOIL this. So I'm going to go over here, and I'm going to use my box method. Okay, so on top is x plus 3, and on the side is x plus 3. Okay, and then we're just going to go ahead and multiply. So in the first box, x times x is x squared. In the second box, x times a positive 3 is plus 3x. The third box, 3 times x is a positive 3x. And in the last box, 3 times 3 is 9. Okay, then don't forget to draw your z. Right? So now I have x squared plus 3x plus 3x plus 9, but you cannot forget to bring this negative 1 down, okay, because that's part of the original equation. And then all you're going to do is combine like terms. So these are my like terms here. So this becomes 6x. My x squared drops down. And then I still need to combine these. So 9 minus 1 gives me a positive 8. And then I'm going to bring my y down. So now I have this equation. So I'm going to slide over and see that the equation that I got, which I'm starring in yellow, is the same as the original standard form. Okay? All right, one more together, and then we're going to move on to a little bit more detailed work, okay? So this one has a little bit more numbers to it, a little bit more work. So what we are going to do is we are going to break it down. Remember, anytime you see this, it just means that whatever's the parenthesis goes twice. Okay, so I have x plus 2, x plus 2, plus 4. Okay, and the first thing I always want to do is my exponent. So in this case, we're going to do our parentheses. So I'm going to go ahead and move to the right, and we are going to use the box method for those two terms there, okay? So, sorry, I drew in two different colors. The top is x plus 2, and the side is also x plus 2, okay? And we know that x times x is x squared. The second box is x times 2, which is 2x. The third box is x times 2, which is positive 2x. And then 2 times 2, which is 4. Okay? Then we're going to draw our z. So now we have x squared plus 2x plus 2x plus 4. Okay? And I'm going to go ahead and combine my like terms. So I have x squared plus 4x plus 4. Okay? Now here's something a little bit different, because now we have to take this and replace it with my parentheses. Okay? So I'm going to erase that arrow, but I just want you to see that. Okay? So y equals -3. In parentheses, you're writing this down. So x squared plus 4x plus 4. Close your parentheses, and don't forget to bring this 4 on the outside of the parenthesis. Okay? And then my next step would be to distribute. So you're going to multiply this 3 to everything inside of the parentheses. So y equals, what is -3 times x squared? -3x squared. What is -3 times 4x? A positive, a negative 12. Sorry. And then a -3 times a -4, which gives me a -12. And then I can't forget to bring that plus down. Okay? And then the last step would be to combine my like terms, which are the two terms at the end. So y equals -3x squared minus 12x minus 8. Okay? So let's see if they are the same. And perfect, they are. Okay? So the whole point of this chart up here was for you to realize that standard form and vertex form will get you the same answer. Okay? They are equivalent to one another, just written in a different way. Okay? So what we're going to do now, okay, is we are going to learn how to find the axis of symmetry when looking at our two different forms. Okay? So last time you learned in class how to find the axis of symmetry in standard form, right? And we used -b all over 2a. So what I want you to do is go ahead, pause this video, and fill all these out using these equations. Okay, so go ahead and pause, and then you can come back and check your answers, and I will have them written there for you, or we'll go over them. Okay, so please pause this video. Okay, so now that you are back, all right, we are going to go over that little box right there. So first we are only looking at standard form and finding our axis of symmetry with using -b all over 2a. Okay, so I'm going to come down here and do some work. So for number 1, my b, so I'm not going to list a, b, and c, okay? I'm just going to go ahead and give you guys the answers. So I have a -4 all over 2 times 1, which gives me a 4 over 2, which gives me a positive 2. So in this box, you should have x equals 2. Okay, for number 2, you should have -6 all over 2 times 1, which gives me a -6 over 2, which then gives me x equals -3. So in this box, x equals -3. Okay, and sorry, I'm just going to move up a little bit. Okay, so now for number 3. I have a -12 all over 2 times a. So now I have a positive 12 all over a -6. So here I should have gone x equals -2. I'm going to write it in that box. Okay? And then for number 4, you should have negative 12 all over 2 times 2, which gives me a negative 12 all over 4, which x equals negative 3. Okay, so that's how those should have been filled out. So that's what we learned last time, okay? Now, when we look at vertex form, it's a little bit easier, okay? Because in this case, we are only looking for h. So when we, on the next page, you're going to see that x, so x is equal to h, okay? So whatever our h is what x is going to equal. So that's only when we're looking at vertex form, okay? So x is equal to h. Okay, so when looking at our vertex form here, we see h is right here, okay? And if you realize that there is a negative in front of it, we have to be careful with that, okay? So when we look at vertex form, you have to be careful of the sign that's in front of the number, okay? Because it's always supposed to be whatever, it's always going to be the opposite of the sign that you see. So, for example, here, you see a negative 2, okay? And I know that the opposite of a negative 2 is a positive 2. So, our x is equal to 2, okay? So, when you're in vertex form, when you're trying to find your axis of symmetry, you have to flip the sign, okay? So, I'm going to go ahead and write that down here. I'm going to erase some of this, okay? We're not going to answer this question down here, so I just want you to write the notes down there. So, when in VTX, that means vertex, okay? So when you're in vertex form, when we look at h, in parentheses, which is equal to x, we need to flip the sign of the number. Okay, and the reason why we do that is because of this negative in the vertex form. Okay, I know it's tiny, but I just circled it. So that's why we need to flip the sign. So I'm going to do number 2 with you. Okay, so when we are looking at number 2, what I want you to do is you're going to look at your vertex formula, and you are going to, whatever x in this parenthesis, it's always going to say x plus something, okay? Always, always, always. So what I want you to do is inside that parenthesis, I want you to square the sign and the number, okay? You are ignoring the x in that parenthesis because we are just looking for h, okay? So here we have a positive 3. So just remember, if we have a positive 3, then my x is really equal to negative 3, okay? So go ahead and try those two. So pause this video and come right back and pause it. I'm going to do the 2 answers and we'll move on, okay? So remember, I want you to box the number and the sign inside the parenthesis, okay? And then x is going to be equal to something. So go ahead, pause the video and do those 2 problems, okay? All right, now that you're back, I'm going to give the answer. So in the parenthesis, we had a positive 2. So I'm flipping my sign, and x is becoming a negative 2. Okay, I'm looking in that last one. I put a square around a positive 3 because that's the sign and the number in the parentheses. And I'm flipping the sign, and I'm getting x equals negative 3. Okay, so when you're using vertex form, it's a little easier to find the axis of symmetry, right? Because x equals is just your axis of symmetry, or it is the x value of your vertex. Okay, so that's something to remember. So this is a little bit easier because you're really not doing any math. You're just looking for the sign and the number inside the parenthesis. So sign and number inside the parenthesis and flipping. Okay. Okay, we are going to do more practice, so don't freak out if you're a little bit confused, okay? All right, on to the next page. So here is where what we did with standard form. So we're just going to go straight into some examples, okay? So like we learned on the last page, I want you guys to give this a highlight here, okay? So the axis of symmetry, we just said that. The axis of symmetry is always x equals. And when you're in vertex form, your x is always equal to h, okay? And we can't forget to flip the sign, all right? So when we are in vertex form, this is important. So this is the biggest highlight you can do, you need, in blue. Highlight it, circle it, underline it, do whatever you need to do, put a star around it, because this is important, okay? Now, when we were completing standard form, we had to do a lot of math to get to our vertex form. To find our vertex, right? We had to calculate the axis of symmetry, whatever we got, we had to plug back in. But with vertex form, it is so much easier, okay? If you see here, I'm going to circle it, okay? This is super important, okay? Your vertex is always h, comma, k. All right? Always. So I'm going to put that there, and then we are going to move it to look like something else, okay? So the first thing I want you to do when we're looking at this example is to find the axis of symmetry, okay? And if you remember what we were just doing on the first page, what I want you to do is put a square around the sign and the number, okay? So remember, whenever we were finding the axis of symmetry, we had to flip, okay? So in this case, h, which is the axis of symmetry, or x, okay, is a positive 1 because we are flipping the sign. Now, these two things are the same, okay? So it doesn't matter if you put x equals 1 or h equals 1, but whenever you plug it back into your vertex form, you're going to see h. So if you want to use h, that's fine with me, okay? So now that we have our h, we could start to plug this into our vertex, okay? So h is 1. So on the first part, I'm going to have a 1 here, okay? And now the second part is even easier, okay? Finding our k. And if you look up in this equation, we have a positive k at the end, okay? And because it's a positive k, we are not switching our numbers, okay? So whatever number you see at the end of that equation, okay, so here we see a -5, that is what our k is. So the second part of my vertex is a -5, okay? So now you found your vertex. Pretty simple, all right? So then from there, just like we did with standard form, you're plugging that into the middle equation, into the middle box. And I'm going to put a V so you know that that is the vertex, okay? So from there, just like we did yesterday, you are going to go one number left of 1 and one number right of 1, okay? Because we still need to find 2 other points. So same thing that we were doing the other day, but now you are going to plug, every time you see an x, we're going to plug in a 0, okay? Now, this is all about PEMDAS, okay? We've learned PEMDAS 1,000 times. So the first thing we need to do is worry about our parenthesis. So we need to worry about what's inside of our parenthesis. So 0 minus 1 is a -1. My squared is still not gone away, okay? So that is the parenthesis part. So that was p. Now, we still have an exponent, okay? So now we need to do the exponent. So we have y equals 2, and then -1 times -1, because that's -1 squared, okay? And we know that -1 times -1 is a +1, okay? And then just the simple math after that. 2 times 1 is 2 minus 5, and in this case, y equals -3. So I plug that in there, okay? Then I need to do the same exact thing, but I need to plug in a 2 for my x. So I'm going to slide over, okay? And I'm going to do it over here. So y equals 2 minus 1 squared minus 5. Okay, so anywhere I saw an X, I plugged in a 2, which was right there. Okay, and what we need to do first is our parenthesis, right? Whatever's inside the parenthesis. So I have X equals 2, and 2 minus 1 is 1 squared minus 5. Okay, then my next step would be to do the exponent. So here I have Y equals 2, and 1 squared is just 1, and I can't forget to bring down my minus 5. And then lastly, you're going to multiply 2 times 1, which is 2, minus 5, and Y equals negative 3. Okay, so I'm going to come back over here. In this case, Y was negative 3, so I'm plugging that in. Okay, and now from there, I am just going to go ahead and graph. So I had 0, negative 3. I had 1, negative 5. And I had 2, negative 3. Okay, and do not forget that this is a U-shaped graph, okay, with this being our vertex. It does not look like a V, okay? So we are going to do one more, and then you're going to try 2 on your own, okay? So the first thing we are going to do is we are going to find our axis of symmetry. So we're going to find H or X equals, okay? So those two are the same exact thing because X is equal to H. So in order to find my axis of symmetry, what I need to do is put a box around the number and the sign that is inside the parenthesis, okay? And once you've done that, you need to remember to flip your sign. So here, I had a positive 1, so my H becomes a negative 1, okay? And don't forget that your vertex is H comma K. So the first number in my vertex is going to be a negative 1. Okay? Then you need to remember that our K, okay, is just this end number with the sign staying the same. So here we had a positive 4, so my K is a positive 4. So that becomes my Y value of my vertex. Okay? And we know that once we found our vertex, we're going to plug it back in right into the middle, okay? And we are going to go right 1 of negative 1 and left 1, okay? Just like we did on top there. But now we have a 0 and a negative 2, okay? So where we're going to go from there, all right, we are going to plug in a 0. So Y equals 3. Now, anytime I see an X, I'm plugging a 0 into the original equation, okay? And same thing, you are following PEMDAS. So the first thing that you need to do is anything inside the parentheses. So we have Y equals 3. 0 plus 1 is just 1 squared plus 4, okay? I then have a squared, so that's my next part of PEMDAS. So now I have Y equals 3. And 1 squared is just 1. Okay? And then the last little math, 3 times 1 is 3. So in this case, Y is equal to 7. Okay? So you've completed that with 0. Now what you need to do is go ahead and complete it when you're using a negative 2. So Y equals 3, in parentheses, negative 2, plus 1 squared, plus 4. Okay, so remember, sorry, it's a little bit confusing. Remember, we always do what's inside of the parentheses first. So I have Y equals 3. Negative 2 plus 1 is a negative 1. Don't forget your squared, plus 4. Then we do our squared term. So now we have Y equals 3. And negative 1 times negative 1 is just 1. Okay, and then we just do our simple math. So 3 times 1 is 3 plus 4, so Y equals 7. So that becomes our other point. And then what you're just going to do is graph. So we had 0, 7. We had negative 1, 4. And we have negative 2, 7. And a nice U-shaped graph. Okay? So what I want you guys to do is go ahead and flip and try these end. All right, so you are just taking over these notes, and you're then going to complete your homework, okay? Your homework is just like this page, all right? So everything that we did here, you're going to do on your homework. Now, what I realized is I didn't have this here for you. So all this vertex and the axis of symmetry in the chart, that's not there for you. So what I want you to do on your homework is near every graph, I want you to write vertex in a line, axis of symmetry in a line, and then a little box that has X, Y, and 3 places so you can write. Okay, so on your homework, you need to draw this on every single problem. Okay? Sound good? If you have any questions, please let me know. Actually, we're not going to worry about that. Okay, so that is where I want you guys to